All right, so I'm going to do a few more proofs. I'll do a couple mixed proofs for proving triangles congruent, and then I'll do a couple CPCTC proofs, and then you will be on your own to practice and do your quiz. So let's start with, this is on page, 1 minute, this is page 53. Number 2, given segment BD bisects angle ABC, and angle BAD is congruent to angle BCD. So let's go ahead and mark that up. If segment BD is bisecting angle ABC, we can go ahead and say these are congruent. So we'll make sure we identify that in the proof. And then angle BAD is congruent to angle BCD. So let's start with our given of segment BD bisecting angle ABC, and that's given. And then because of that, we can say that angle ABD is congruent to angle DBC. So ABD and DBC are congruent. And that is by definition of angle bisector. Okay. And then now we just showed an angle relationship. So let's put that A there. We have another angle relationship with the other given, so angle BAD is congruent to angle BCD, and that was given. Oops, sorry, my screen moved there. Given. There's another angle relationship. So if we go down the list of all the SSS, SAS, AAS, ASA, all the lists, we've got 2 A's, so let's see if we can get a side. It looks like we have a side congruent with BD. If we're looking at triangles ABD, we're trying to prove that this triangle is congruent to this triangle. So we do have side BD is congruent to itself, a reflexive property. And so we can conclude that triangle ABD is congruent to CBD. Yep, corresponding parts are all matching there. Perfect. So triangle ABD is congruent to triangle CBD, and that is going to be by angle, angle, side. Angle, angle, side. Since this is not the included side that we proved congruent, it's not ASA because it wasn't the included side that's between the two angles. So it was angle, angle, side. So at this point, what I'd like you to do is I'd like you to independently practice through the congruent triangle proofs mix that you'll find here on page 53 and 54. And then the answers will be posted in Canvas for you to review. We've done a few of these together, but there are still a few that are blank that you can try on your own for practice. So now let's jump over to page 55 and do one more review of a congruent triangle proof where we are proving the corresponding parts congruent. So in order to prove corresponding parts congruent, first we have to prove that the triangles are congruent. If we don't do that, then we cannot use CPCTC to prove that parts are congruent. And we've discussed this already. So let's do one more example. And that example will be number 2. Okay, so for number 2, we are given that PS is parallel to QR. So I'm just going to mark that up. Little arrows, and angle QPS is congruent to SRQ, and we need to show that PQ is congruent to RS. So plan of action here, I do have 2 triangles, number 1 and number 2. If I can prove that these 2 triangles are congruent, then I should be able to prove that these sides are congruent by CPCTC. So that's my goal here, right? Looks like I have angles congruent in these 2 triangles, and I also have a side congruent in these 2 triangles. So if we can build our proof, kind of a rough draft here, we have angles congruent, we have sides congruent. Can we either get another side or another angle congruent? Like, should we do an SAS, or should we be doing an AAS or an ASA? Well, here's the thing, guys. They gave you a clue about parallelism. And if you see a clue about parallelism, that's an angle clue. That's an angle congruent clue. So once you see those parallel sides, that's an angle congruent clue. So let's see if we can find it, okay? If PS is parallel to QR, and we look at this transversal, then we should be able to show that these alternate interior angles right here and right here are congruent. I always draw a little bit off the line and you can't see my angle right there. Okay, so we should be able to show that this angle and this angle are congruent because when two parallel lines are cut by a transversal, the alternate interior angles are congruent. If we do that, then we show another angle congruent and we're able to use AAS. So let's build that proof. We're given that PS is parallel to QR. And as a result, we can conclude from there that angle PSQ is congruent to angle SQR, alternate interior angles. All right. So there's one of the A's. We're given the other A, QPS, is congruent to angle SRQ. That was given. All right, so there's the other A. And then I think we have a side because they share this side. So side QS is congruent to SQ or QS to itself, reflexive. Okay, so again, remember that the goal is to prove that these sides are congruent, but we can't prove those sides are congruent until we prove that the triangles are congruent, because first comes triangles, then comes CPCTC. So triangle, let's make sure we call the triangle correctly. If we're going to say PSQ for the first triangle, let's call it PSQ. If we're going to say PSQ, then we have to say RQS to make sure that the corresponding parts all match. PSQ, RQS. PSQ, RQS. And now those are congruent. Those triangles are congruent by angle, angle, and side. Let's make sure it's not ASA. So it was this angle, and this non-included side. So it is AAS. And then as a result, let's make sure everything matches. We had to prove that side PQ is congruent to side RS, and it does match. So PQ is congruent to RS, and that is by CPCTC. Okay? So now what I want you to do is go into page 56, and you've got some blank ones in there, and try those out and practice and check your answers on Canvas. And then you should be good to do the rest of the assignments for the day. Thanks for watching.